Okay, great. So today we're going to look at domain and range. And just in the entire time in your head, you should be thinking about, okay, what is domain? What is range? How do I determine these things? So domain is the set of all possible values for x of a function, and range is the set of all possible values of y for a function. We can find the domain and the range of a function using graphs or using algebra. So we'll look at two different methods. So starting with graphing, we can determine the domain and range of these functions. And we can use set notation and we can use interval notation. Okay, so if we're looking at this first graph here, and we want to find the domain, we want to state all the possible values of x. Notice this, this function has an x value of -1 at this point here, and it goes all the way forever towards infinity, positive infinity. So x starts at -1 and it goes towards infinity. So we can say x is greater than or equal to, because that point is filled in, -1, or we can say it's between -1 and infinity. And we include -1 because it is a filled in point, but we never include infinity. And then to find the range, this is in terms of y, so we look at all the possible values of y. And we can see from our graph that and we always go from smallest to largest, that's a really good point. So we can see that y is going from -3, this point right here has a y value of -3, and it's going all the way towards positive infinity. So we can say our range is y is going to be greater than or equal to, because that point is filled in again, -3, or we can say it's going from -3 to infinity. So you choose whether you want to use set notation, this one, or you can use interval notation, either way. Okay, this second one, the domain here. If we think about it, we've got arrows pointing in both directions. So the domain of this function is really from -infinity to positive infinity. X can be any real number. So we say domain is x is an element of the real numbers. It can be any real number. Range then. So range, we can see y is at its maximum at 2, and then it's going towards -infinity. So we've got from 2 to -infinity. Y is going, these arrows point towards a y of -infinity. So we want this in order, so we can say from -infinity, not including that, to 2, but including 2 because that point's included. Or we can say x is less than or equal to 2. Or sorry, y. Range. Y is less than or equal to 2. This one here, we can see our x is going towards -infinity in this direction, and it's going towards positive infinity in this direction. But look, we have a vertical asymptote at x equals 2, so our function actually x never equals 2. So our domain, we can simply just say, is that x doesn't equal 2. We can see it equals any other real number, just not 2. And then our range, so if we think about y, same thing, right? Y is going towards -infinity. It's also going towards positive infinity. So it's all real numbers except it doesn't equal 1. Y never equals 1 on this function. So our range, we can simply just say y doesn't equal 1. And that implies the domain is all, or sorry, the range is all real numbers except 1. Okay, finding the domain and range of these functions. Again, you can use set notation or you can use interval notation. So in this example here, I'm just going to go through them a little quicker. Domain is going to be all real numbers. X is an element of all real numbers. And that's because our x values, it's going towards negative infinity, and x is also going towards positive infinity, and everything in between, all the x values in between are included. Range, it looks like, range, it looks like this is the point 0, 3. So our range is going from negative infinity to 3. 3 is our maximum. So we can say y is less than or equal to 3, and it can be equal to because that point's included, or we can say that our range is going between negative infinity and 3. And again, these have to be in order from least to greatest, so negative infinity to 3. Okay, domain in this second one. We can see it's going from, x is going from negative 2 to, I guess we'll assign this a value. This is not an arrow, so we'll say that's 4. Okay, so our domain, we would not include negative 2 because that's a hole there. So we can say x is less than or equal to 4, because this point is filled in, or greater than negative 2, but not equal to negative 2 because here we have a hole. Or we can write that as not including negative 2 and including 4. Our range, what do we got from y is 0 to y is 2. And again, we're not going to include 0 because that point is not included. So our range is y is between 2 and 0, not including 0 because this point here is a hole. Or we can write that in interval notation, not including 0 to 2. Either one works. Okay, letter C. Again, our domain here is all real numbers. You can see x is going towards positive infinity, it's going towards, negative infinity, it's going towards positive infinity. It covers all real numbers. So x is an element of all real numbers. The range. So it looks like we're going from negative infinity with our y's all the way up to 8. So from negative infinity to 8, not including negative infinity, but including 8. Or you can write that as y is less than or equal to 8. Okay, domain here, all of the x values, it looks like x goes from negative 3 to 0. So from negative 3 to 0, including both of those points, and from 1 to 3, again including those values. Or we can write that as x is less than or equal to 0, or greater than or equal to negative 3, or between 3 and 1. Range. Range, we're looking at y values. So notice that y, we have to know this point. Let's say that's 1. So y is just simply going to go between 0 and 1. So the lowest y value is at this point here, where y is 0. So y goes from 0 to 1. And it includes both those values, or we can say y is between 1 and second one. Again, we need to know these points. So let's say this is -1 and +1. So our domain is going to go between x equals -1, which is at this point, to x equals +1, but we're not going to include the +1 because this is a whole. So from -1 to +1, but not including 1, or you can say x is between, not including 1. So x is less than 1 or greater than or equal to -1. Either one. Range. So range is our y values. If we look at our y values, we're going from -1 here all the way to y equals 1 here, but it doesn't actually ever equal 1 because, again, this is a whole. So we'll say from -1 to 1, but just not including 1, or we can say y is less than 1 or greater than or equal to -1. And again, you don't need to write both of these. If you prefer set notation over interval notation, that's fine. You can just use this form. If you prefer interval notation over set notation, you can just use this form. That's fine. Okay, I believe this is the last graphing example. Our domain here is, we have a vertical asymptote at x equals 0, which you can see here, vertical asymptote. Therefore, our domain is that x doesn't equal 0. Because if you look, the x values are going between -infinity and infinity. X just never equals 0. It never touches the y-axis. So it's our domain. Our range is same thing. Our y values are going from -infinity towards infinity, which implies all real numbers, but look, y never actually touches the x-axis, so y never equals 0. Okay. Oh, okay, a couple more. Domain and range here, so we've got a domain from -infinity to -2. Or you can write that as x is less than or equal to -2. And again, we can include the equal sign because that point is included. So x goes from -2 all the way to -infinity. Our range okay, oh, that's not right. X is 8. Okay, try it again. Domain is going from -infinity to 8, because that's our x value here, including 8. Okay, so x is going to be less than or equal to 8, our x value. Right, so then range is going from -2 to infinity. Y is going towards infinity, positive infinity. So we can say our range is going from -2 to infinity, not including infinity, or that y is greater than or equal to -2. Okay, here, domain. If you look, our domain is all real numbers. We've got x is going towards -infinity in this direction, it's going towards positive infinity in this direction. Every point in between, every x value is included. So x is all real numbers. Range is going from y is -1 all the way to y is infinity. So from -1 to infinity, we can include -1 because it's a frozen circle, don't include infinity, or we can say y is greater than or equal to -1. Okay, domain and range using algebra. So graphically, at least we have a picture. There's something we can reference. Algebra, we have to think about two different things. One is that it is impossible to divide by 0. We can never, ever divide by 0. So we have to look at, if we're given a fraction as our function, if we're given a rational function, we need to take a look at our denominator and think, okay, x plus 2 cannot be 0. So we have to think, okay, x plus 2 cannot equal 0. Okay, so if we're finding our domain, x plus 2 can't be 0, we can minus 2 to the other side, which gives us x cannot be -2. So this is our domain. When we're looking at a rational function, we're first going to examine the denominator and make sure that it does not equal 0. Then we're going to solve that for x. So our domain here is that x cannot be -2. Okay. The other thing that we have to pay attention to when we're using algebra to define domain is we can't have the square root of a negative number. We can do the square root of 0, we can do the square root of positive numbers, but we cannot have square roots of negative numbers. So x plus 3 has to be positive in this example, which means x plus 3 has to be greater than or equal to, positive or 0, greater than or equal to 0. Again, we can solve this by isolating x, so we get x is greater than or equal to -3. And that's our domain. So the domain of this function is that x has to be greater than or equal to -3. Okay, so when you're finding domain using algebra, please pay attention to these two things. It is impossible to divide by 0, so you have to check, could your denominator ever be 0? And we cannot have the square root of a negative number. So anything underneath the square root, we have to make greater than or equal to 0. Okay, so we're going to find the domain of each of these functions, and then we'll look at finding the range as well. So the domain. In this first one, we're given a square root, and you should think to yourself, we can never take the square root of a negative number. Square root. This is what we're thinking, which means whatever is under the square root has to be greater than or equal to 0. So if we're finding the domain, this is the work that we show. So x minus 5 is greater than or equal to 0. We can add 5 to both sides, which gives us x is greater than or equal to 5. And that's it. That's our domain. Okay, so looking at the next example, again, we're going to think the same thing here. We can never take the square root of a negative number. And we just want to make sure that x squared plus 2 is greater than or equal to 0. If we minus 2, like here, if we minus 2, we're going to have x squared is greater than or equal to -2. And then we're taking the square root of a negative, which doesn't make sense. We can't do that. But if you think about x squared plus 2, there's nothing that you can put in for x that is gonna make this a negative expression. So no matter what negative number we put in for x, we're going to square it. So it'll give us a positive anyhow. So for example, if we put in -1, if we square that, we get 1 plus 2, which is always going to give us something positive. So the reality is that this is always going to be positive. No matter what we put in for x, it will always give us a positive output. Therefore, our domain is not restricted because everything underneath this square root is going to be positive no matter what. So x can be all real numbers. Okay. Example 3 and 4, we're dealing with fractions again. So with fractions, you're going to think we cannot divide by 0. Okay, so we don't want to divide by 0, so we want to make sure that our denominator does not equal 0. So we need to make sure x minus 5 does not equal 0. We can add 5 to both sides, and x does not equal 5 is our domain. Okay, and then here we'll just need to factor our denominator first. -3 plus 2. And we're going to take each factor, and make sure they don't equal 0. So x minus 3 cannot equal 0, which means x doesn't equal 3. And x plus 2 does not equal 0, which means x doesn't equal -2. So our domain is going to be x doesn't equal 3 and x doesn't equal -2. Okay, as far as range goes, so finding range algebraically, there's some different strategies you can take. We'll look at least one. So domain we found in this first example here, right? To find the range, we can take the smallest value of our domain. Okay, so x has to be greater than or equal to 5 here. So we can take the smallest value of our domain, which is going to be when x equals 5. Because x has to be greater than or equal to 5. So when x equals 5, we can find what f of 5 is. F of 5, when we plug that in, we're going to get the square root of 5 minus 5, or in other words, the square root of 0, which is 0. And if you think about it, as x gets bigger, our function is just going to get bigger and bigger and bigger. So if you think about it logically, the range of this function is going to be between 0 and infinity, or that y is greater than or equal to 0. So that's our range there, because the smallest value that y can be is 0. Because the smallest value x can be is 5. Okay, we'll look at that again here. So if we want to find the range of this function, let's think about this. The smallest value that x squared plus 2 can be. I'm just going to erase this. And in your head, for the range, you're thinking, what's the smallest value? Okay, and if you think about it, if we plug in 0 for x, we'll get 0 squared. See, I'm just going to do it to teach it. So if we plug in 0 for x, we'll have 0 squared plus 2, which is going to give us the square root of 2. If we plug in 1, we're going to have 1 squared plus 2 underneath the square root, or the square root of 3. If we plug in negative 1, remember negative 1 squared is still going to give us a positive 1. So again, we'll have the square root of 3. So the smallest value that x squared plus 2 can ever be is the square root of 2. And that's when x equals 0. And it's just going to keep getting bigger and bigger. When x gets more and more negative, this square root is still going to continue to grow because we're squaring our x. So our range is going to be y is greater than or equal to the square root of 2. Or we can say it's from the square root of 2 to infinity. Right here, domain. We've got our domain. Range. I'm just going to hold off on range for those ones for now. It involves asymptotes, and when we look at asymptotes the next day, you'll be able to see that more clearly. So same with example 4. If you're curious, I'll just give you the answer here, but you're not responsible for. In fact, I'll just hold off on that. We'll look. I promise we'll look at that next lesson. Okay, finding the domain and range of these functions. The domain for letter D here. In our heads, we're thinking we can't take the square root of a negative. Okay, so we can't take the square root of a negative, which means x squared plus 4 has to be greater than or equal to 0. If we minus 4, we get x squared has to be greater than or equal to negative 4. And then something weird happens again. We're trying to take a square root of a negative, which doesn't make sense. And that when that happens, that means x can be any real number. This is the domain. Okay. And the reason that is because if you think about it, x squared plus 4, same thing, it can never be negative. No matter what we put in for x, no matter if it's positive, if it's negative, we're going to square it anyhow, and that's going to give us a positive number. And then when we add 4 to that, it's still going to be positive. So it's never going to be negative, which means we can put any value, any real value in for x. Okay, as far as range goes, we have to think about, okay, well, what's the smallest this function can ever be? If we think about our t-chart, when x is 0, we're going to get the square root of 4, which is 2. When x is 1, 1 squared is 1, so 1 plus 4, we've got the square root of 5. And same thing with negative 1. When we square negative 1, we're going to get a positive 1 plus 4, which gives us the square root of 5. So notice the smallest value that this function can ever be for y is 2. So our range is going to be y is greater than or equal to 2. And we can also write that using interval notation from 2 to infinity. Okay. And we know it's greater than or equal to 2 because look, the function is just going to keep getting bigger and bigger. Our smallest is the square root of 4. If we plug in 1, we get the square root of 5. If we plug in 2, we'll get the square root of 8, and so on. Even negative 2 will give us the square root of 8. So it's just going to keep growing and growing. Okay, for E, again, we want to be thinking we can't take the square root of a negative. So we need to make sure that x squared minus 4 is greater than or equal to 0. So that means x squared is greater than or equal to 4. And we can actually take the square root here. Okay, but we have to be careful. So not only is x going to be greater than or equal to 2, but remember when we take the square root, we do plus or minus. And that minus, because we're dealing with an inequality and we're basically dividing by negative, x is going to be less than or equal to negative 2. So x is either going to be greater than or equal to 2 or less than or equal to negative 2. And that's our domain. And again, that just comes from the idea of when you take a square root, you have plus or minus. So do what you normally would do with the plus. So keep your sign facing the normal, the way we have it greater than or equal to. So we say x is greater than or equal to positive 2. And then you flip the sign for the negative. So x is less than or equal to negative 2. Range. We need to look at the smallest values of our domain, and that's going to help us determine the range. So we're going to think about when x equals 2. And by smallest values, I guess we're really thinking about the smallest absolute values. We can also really consider when x equals negative 2 as well. So when x equals 2 or when x equals negative 2, we're going to think about these. Okay, so we want to find f of 2, which when we plug into 2 squared minus 4, which is going to give us the square root of 4 minus 4, which is the square root of 0, which is 0. Okay, same with negative 2. F of negative 2 is going to give us a negative 2 squared minus 4, which we know negative 2 squared is actually a positive 4, which is the square root of 0, which is also 0. So and it's going to continue to grow from there. If you plug in 3, you can see the function's going to get bigger. You'll have 9 minus 4, which is 5, and you'll have the square root of 5, which we know is bigger than 0. So our range is going to be y is greater than or equal to 0. You could also write this in interval notation from 0 to infinity. Okay, last one. We're just going to look at the domain here. Again, we'll think about the range once we learn about asymptotes. So domain, right. In your head, you're going to think, look, we're dealing with a fraction, so we cannot divide by 0. Okay, so we want to make sure that x minus 2 does not equal 0. Our denominator doesn't equal 0. If we add 2 to the other side, we get that x does not equal 2. And that's our domain. And again, we'll look at range when we look at asymptotes. Whew, so that's it. Thank you.